Everybody. I hope you had a nice break. And now with this, I'm very happy to introduce our guest lecturer today. So as I described, we're going to talk about the idea of how do you create that kit of parts and what are the software solutions that can do that. So a great pleasure to introduce Mike Eggers, the Vice President of Product and Innovation at Project Frog. And Mike and I have actually known each other now for several years, both in the San Francisco Bay Area, through the Stanford Industrialized Construction Forum, and just keeping in touch with their great developments. So very pleased that Mike can join us. And Mike, from here, please feel free to share your screen and take it away.
Thanks so much, Daniel. I will get my screen shared here. So like I said, before I jump into KitConnect, I'll give an overview of Project Frog, a little bit about our history. So we've been around for over 14 years now, with a focus on designing and developing prefabricated building systems or kits of parts. We're a little different than a lot of other prefab companies that you might know of. We're not a vertically integrated company, meaning we don't own factories. We work with a distributed network of manufacturers, and we also don't self-perform in the field. So we work with a number of different architects, engineers, builders, general contractors, whenever we execute a project. So we develop a kit of parts. We work with a distributed network of stakeholders to then on a project delivery mechanism. A lot of our history, throughout our entire history, we've focused on this idea of a componentized or kit of parts approach to allow maximum flexibility within a prefabricated building system. And we know that flexibility is really important. People want buildings how they want them. Buildings are very expensive and they last a long time. So people want the ability to customize them kind of to really suit all of their different needs. And we've developed these different kits of parts across different various building typologies. So we've done a lot of work in education. We're probably best known in K through 12 education, but we've also done some buildings in healthcare, medical office buildings, data center design. The Golden Gate Bridge Pavilion, if you're ever in San Francisco, is one of our more visible buildings. And these days we're also doing a lot of quick service retail buildings or fast food buildings. So we've explored flexibility, kits of parts across a lot of different building typologies. And a core piece of figuring out how to scale these solutions was applying a technology approach very tightly coupled to that kit of parts to enable scale. Now, this started out as an internal technology effort at first, building some internal tools to enhance our ability to rapidly go from a preliminary design with a set of rules, or sort of a rules-based design system with a flexibility approach, and then very quickly push that into production for things like producing Revit drawing or Revit models for all of our construction documentation, shop drawings, and then bill of materials to push into manufacturing. We were fortunate to show that technology to Autodesk back in late 2016, early 2017. That led to an investment from Autodesk that really was the sort of trigger point for us to then pursue morphing our internal technology into externally facing software that we now are selling globally, and that software is KitConnect. We formally launched it last fall. So we just launched KitConnect last fall. We're aggressively going to market with it. So I'll spend most of the time talking about KitConnect today and some examples of how we use it in various workflows and the various personas that we're targeting or users we're targeting with the software. Before I get into that though, I can advance my slide. So I mentioned earlier, there's a big focus on scalability with our business. And from our standpoint, scalability really is the differentiator between prefabrication and industrialized construction. So just thinking about industrialization, that implies delivering at scale. And to us, really the way we approach that scalability factor is we really think you need both a kit of parts and a technology platform. So these two go hand in hand. It's possible to have a kit of parts platform, but not if you don't tightly couple it to any kind of technology, meaning some amount of automation, as any kind of scalable approach there from the technology side. Without these two going hand in hand, you'll never be able to scale the solution. In the inverse, you could have great technology. In our opinion, without that kit of parts, the problem becomes too complex to really drive at scale. So these two going hand in hand, very, very important. And I think the great thing about our business, given that we are both still delivering buildings, we're very active, still designing, developing prefabricated building systems and developing technology. We're not, developing technology and then looking for a problem to answer. We're able to drive that back into our own processes. So KitConnect is really born out of this constant pursuit now over 14 years to solve this problem. So we know the problem very well, and we're able to test it very well. It's kind of like having our own internal lab with our design team. So when we look at a kit of parts, some of the key ingredients that we think are critical to create a scalable kit of parts, aside from just a technology approach, are these sort of three hallmarks. The first one is design for configuration. So flexibility, again, is very, very important. If you design a kit of parts properly, you should be able to allow for, it sounds almost crazy, but millions or billions of possible design options with a good kit of parts. It doesn't take many design options, honestly, before you get into millions and billions of different variations. So maximum flexibility, designing that for configurability is really important. So the next problem that will arise if you have a configurable rules-based system is how do I work with it from a design standpoint? How do I assemble that? What are the rules and the constraints around that system? How do I push that into production from engineering, design, documentation, manufacturing? So you're going to need some amount of automation to allow this, again, to scale. If you don't have any automation in the chain, the system will become too complex to be usable at scale. And then the last piece that we can't overstress is design for usability. It needs to be easy to use. It needs to be intuitive. And this is actually one of the biggest barriers for architects and engineers and builders to take on prefabricated building systems or industrialized construction. It's an unknown in the industry still. So what are the rules and constraints? How do I work with the system? How can I put these parts together? What are the do's and don'ts? So making that easy, seamless, obvious, and working within existing technology stacks, existing known workflows is a very important piece of the puzzle to make it usable and hopefully, we like to say delightful, if that's possible in construction, and make this an easy process. So these three going hand in hand really help drive scalability. Going back to configurability, we know that configurable platforms are a proven solution for scale. If looking at other industries like the car industry is a great example. Having variability introduced into the system with some uniform areas and other variable areas allows car makers to have a lot of standardization to build at scale, but still give consumer choice, right? So this is a very known approach in other industries, consumer electronics, automotive. The difference, though, that we would say in AEC is that variability in AEC is actually orders of magnitude more complex. You have variability kind of at every step along the way. Variable owner requirements, right? That could be programmatic, aesthetic, site conditions, right? Vary, so that introduces different regulatory variables, building code, planning code, structural solutions, soil conditions, right? So tons of variability from just a site standpoint. And then the last one, which I think is very different than automotive or consumer electronics, the teams are ad hoc, right? So there's a ton of variability in the team. Typically, a team gets reassembled on every single project, and that's from, if you're an architecture firm, you're probably reassembling that team within your own company, but certainly across the whole chain of stakeholders from designer, engineer, builder, construction manager, manufacturer, supply chain manager, owner's rep, all the different players. These teams get reassembled every time. So how do you work with teams that are constantly changing, that don't have full knowledge maybe of the system they're working with, don't know all the different systems and how to work between each other. So a lot of variability there. So all of this kind of comes together to create a much more complex problem than anything in automotive or in consumer electronics. And that's why, from a technology standpoint, we believe you can't just look at sort of take off the shelf solutions from other industries and apply them to AEC. We need to come up with solutions that are technology solutions that are unique to this market, unique to this space, and really drive toward the unique demands of an AEC team or a set of stakeholders. So now that I've kind of given an overview on the Project Frog approach and some of our history, I'll dive into KitConnect specifically. And first, I'll give you an overview of some of the sort of the ROI arguments or the value that we're attempting to deliver on a project or a building as a product. So again, sort of three key hallmarks here. Number one, we want to unblock design for configurable DFMA content. So I talked about usability earlier, how to make this easy. This is a big barrier to working with prefab systems or rules-based systems. There's a lot of time spent, even in more traditional workflows, but it's more severe with prefab content. If I'm a designer, there's a lot of time spent trying to understand what are the constraints of the system. What pieces can I put together? How do they fit together? What can I do and can't I do with the system? So how to unblock the design for configurable content, make that very easy and seamless to use in a familiar environment like BIM or Revit. The next piece that we focus on heavily is how to improve the handoff from design to manufacturing. So if you think of in the first stage, unblocking design, that is time wasted. So that is certainly risk and cost that gets incurred by just wasted time or miscommunication. When we get into handing off to manufacturing, now your risk profile goes way up, right? So if you think about an error gets to the factory floor and that's discovered, you might have to stop that factory line. That's extremely costly. You might have to send something back to design. You might have to, at the worst, tear something out of an existing module or something that's already been built. So your risk profile, your cost profile goes way up as you move from that handoff into design manufacturing. And we want to make sure that we have a very seamless, tight, high fidelity handoff from our BIM environment using building information modeling over to the BOM, the bill of materials that gets handed off into manufacturing. We have some interesting functions, automated functions like the ability to audit the model and sync that BOM that I'll show some examples of. And then the last piece, which is very important, is how to just enhance the continuous improvement process across those components and their whole life cycle. This will talk about how to open up these workflows beyond just the Revit environment. Or the BIM environment and open them up into the cloud, allow other stakeholders to participate in that workflow and make sure that we don't trap that information or trap that logic in a system that's only accessible to a small group of people. So by opening that up, allowing participation on the data flow across all stakeholders in a familiar environment, they have the ability to update and enhance those components along the way. So broad stroke overview of what is KitConnect. It's an integrated Revit to web solution to create, develop, and manage configurable modular kits and parts content. So there's two components to this, a Revit plugin and a web application. Probably a lot of you are familiar with Revit, so I won't belabor that too much, but if you're not, that is a very dominant BIM solution provided by Autodesk. So we have built this, we are partnered with Autodesk, so we've focused on Autodesk products to date, but these two components, the Revit plugin and the web application, work hand in hand. to allow easy data exchange between these two environments. And I'll show some examples of how these work together in a moment. And the end-to-end workflow that we're addressing here is, it all starts with developing that kit of parts. So this is developing a library of content. And we're really focused on more than just the content at this stage. It's also capturing the logic or the rules and constraints around that content. So that person or that team is developing that information, publishing it to the cloud using our Revit plugin. The next step then is moving into building design. Now I have you have a great kit of parts. Now I have to design a building with it. So things that we're concerned there, it seems simple, place, edit, audit, but it's really making sure that the constraints that were established when you're developing the content library are adhered to when you have potentially a different team designing a building with that kit of parts. Again, using our Revit plugin, we're able to constrain that environment and put a high level of automation around making sure that model is very correct and accurate. Then when we get into manufacturing and construction, we focus on what we would say is quantify, verify, making sure you get an accurate bill of materials out of that BIM context from your Revit model, so you have a really highly accurate handoff that you can hand over to manufacturing. This is primarily done in our web application. There's some bleed between these, between our Revit plugin and our web app across these stages, but it's pretty much how they break out most broadly. So when we talk about kit of parts a lot, KitConnect being a kit of parts manager. So what is a kit of parts? And it's really any rules-based system of reusable components that could be mixed and matched, right? To create, like I said, millions or billions of different design possibilities. So this isn't constrained to modular or volumetric. It's really anything that you would define as a kit of parts. And we're even seeing some customers or some companies that they're not even fully into industrialized construction or prefabrication. They might be early stages. They may be looking toward migrating a part of their business over to industrialized construction, but they're still working in kit of parts approach, meaning they have very repeatable design elements that they're using again and again. They have a certain set of design guidelines or design constraints that they want their company to adhere to. So these are even in this early stage where you may have defined components and you're looking to eventually get those into a manufacturing workflow. This is still a very valuable way to approach the problem. The more you are pushed into manufacturing, the more you'll take advantage of the full capability of the software. But really, it's as you can see kind of from this diagram, it's anything from flat pack panelized construction to full volumetric to MEP systems. It's really up to the customer how you define, or the user how you define a kit of parts. And this, again, just to kind of emphasize, we'll talk about a module a lot. A module is kind of a core component of KitConnect. But when we talk about a module, that's really just a flexible or configurable object or a collection of objects. So people tend to think of a module as this thing in the top left-hand corner here, a pod or a volumetric unit that's built in a factory. That is certainly a type of module that we can handle using KitConnect. But again, it's a very flexible definition with KitConnect. It could be a building system. It could be a whole building. It could be something as small as a wall panel or something even, a smaller assembly. Another great example would be a modular furniture system, right? That's a rules-based system that certain parts go together in specific ways. A certain furniture line might have a whole set of parts that are able to be assembled together that would have rules and constraints around them. So the key thing that we're trying to solve for here is how to handle flexibility and configurability with a module and control for that in your BIM environment. Another core concept to hit home before we kind of walk through workflows is this concept of a data recipe. And this is actually probably one of the biggest core concepts that we're dealing with from going beyond the limitations of current tools and workflows. So if I think the promise of BIM was that you're going to be able to handle all of your information, right in your Revit model or your ArchiCAD model, right? Everything can be handled there. It's going to be this beautiful world. And that really has not proven to be true in the industry, even outside of prefabrication. There's lots of information around that building. It's not going to be captured in the model. It's not going to be managed there. So what we've wound up with is, you've got a certain set of people that are expert in BIM, that know how to use those tools. They wind up becoming data managers in a way. And then sometimes they're redundantly managing that data in a BIM context, or there's just other information that they're not responsible for. It's managed in another system. There's no good way to make these systems talk to each other. So what we're trying to do here from this data recipe standpoint is a few things. One, primarily, is free up the data beyond the confines of BIM or Revit. And to explain how we're doing that a little bit, the only thing that we store on a file level is an individual part. So if you're familiar at all with Revit, that would be a part would be a Revit family or a .rfa file. So at the most granular level, a single part would be an actual file, a file store. We'd store that file in the cloud with some information along with it. But when I get to something like an assembly or a full module, which would be a collection of parts with some rules and constraints assigned to it, this is really just a data definition or a data recipe that lives in the cloud, refers to those individual parts of those individual file stores. So we're moving away from file stores as much as possible. And the primary reason for that, again, is to free up that data outside of the confines of your BIM context. And then that data can be used in other contexts or other environments like the web or other authoring tools. So this is the primary reason we're doing this, is to really let that data be opened up and accessible to other individuals that aren't just your BIM user. And we'll show some examples of how we're freeing that data up. The other reason we do it from a scalability standpoint is, let's just take an example again of that individual part. A part in a prefab system will be used again and again in different contexts, different assemblies, different modules. So let's say that single part is used in 1,000 assemblies and 2,000 different modules in your whole kit of parts library. So now if I was handling all of those modules and assemblies as files, I would have 3,000 files that I need to update every single time the part changes. So this wouldn't be a very manageable or scalable system. If it's a data recipe and just referencing those individual parts, if the part updates, that module would then just reference that up-to-date part. If I insert it in my Revit model, I'll just go get the most up-to-date parts. So it's a very scalable way to handle the data, and with the added benefit of freeing up that information to other users. So let's now talk about some core concepts to create scalable DFMA workflows across certain key stakeholders along the chain. So again, starts with your kit of parts design. We call this user or set of users a kit designer. So these are individuals typically in an organization that have a high level of expertise and knowledge around that kit of parts or those individual building components. So they know the rules and constraints. They typically know the fabrication details. So highly knowledgeable, usually a smaller set of individuals in an organization that is designing and developing that kit of parts. So the aim here is to free up that information. Is typically a lot of times really trapped in these people's heads, and put it in a system that is scalable and reusable outside of just these kit designers. So publishing those parts and assemblies and modules to a digital cloud library, and very importantly, publishing the rules and logic maintained along with those components to the cloud. The next step then, now I've got, again, that kit of parts well defined. The next problem is now I have this ad hoc team. It changes all the time of architects, engineers, and various consultants designing a building. Typically, this is not the same people that are developing the kit of parts. It's very typical that these are different teams, different individuals. So they don't have that really deep, nuanced knowledge of all the rules and constraints. They're knowledgeable about how to put buildings together, how to design buildings, regulatory requirements. So the aim here then is, how do you make this easy and constrained, right? You want to make sure that they take that kit of parts and they design a building that can actually be assembled, can be manufactured, and can be built on site. So the focus of KitConnect here then is constraining that team within those set of constraints and logic established by the kit designer. It's really, at this point, operating more as a configurator than a content manager to constrain that team. And then the last piece is how to create data-centric workflows. We are not claiming to do this comprehensively by any means. This is a huge problem. But by opening up those workflows beyond the BIM context, using that data recipe, and exposing it in other easy-to-use environments like the web, now we have the ability for other stakeholders, construction managers, supply chain managers, general contractors, to access that data, edit that data, really participate in that data flow, and push that information back to the Revit user as well. So these two systems work together. So we're creating integrated data flows across the whole set of stakeholders across a project. And this, again, just allows as much as possible a single source of truth for that information to occur on a project. So let's look at these problems one by one, and then how KitConnect solves for them. And I've got some videos along the way that will show some examples of how this works. So on the content and rules management, the first problem here is this is typically distributed beyond BIM, right? So your content or your rules are typically, you've got your file store handling your BIM content, rules and logic, your DFMA rules. This may be in PDFs, this may be managed in some other system. Parts tracking could be in spreadsheets, it could be in an ERP system. The point is that all of this information gets distributed in different places, different disjointed systems that are then distributed across multiple projects with multiple ad hoc teams. So if there's any change that occurs along the way, it's very difficult to manage that change, push it through the system, and keep all of this information updated. With a KitConnect approach, what we have here is an enterprise library of content. The rules and DFMA rules and logic are associated directly with that content for your parts, modules, assemblies, and building systems. That's developed by that kit designer using our Revit plugin and web application. And they can push that content down to the project level and be consumed by your design team using a Revit plugin. And you can manage change across the enterprise and project library. So all of that information of parts tracking, rules tracking, content tracking is automatically integrated and in one single source of truth. We have automated version control built in, so it's very easy to manage change, and we're able to gate changes between that enterprise library and the project library. So I'll show an example, just a simple example of publishing some content from our Revit environment, and we'll show how that will populate our content library in the web. So on the right side here, we have our web application. On the left side is Revit, and with our KitConnect plugin installed. And we're just going to publish some content directly from the Revit context. We're going to select some of those Revit families and publish them out as parts. So we're doing a batch publish here. And you can see that when we batch publish, it's going to grab some of the parameters off of those Revit files. In some cases, I can create some custom metadata for things like part number or description. And once we enter some information, we'll batch publish that. You'll see them drop in one by one in our content library and start populating our content library in the web. Now, once I have a fully populated content library, I can go into our web application. I can query that information. If I want to drill in and get more specific info on a part, I can edit some metadata there, save that metadata edit. That will push back to my BIM context. You can also observe modules that we published in the web. In some cases, we can do lightweight editing if you have user permissions to do so. So I can do things like turn parts off. That will remove them from my Revit model. And then this is a quick example of a bill of materials from a fully populated Revit model accessible via our web application. So again, that data is accessible now beyond just your BIM user in an easy to use context. So the next problem is in building design. So constraints are great. Our designers use constraints all the time. This is typical for everybody working within some kind of constraints, whether it's budgetary, site constraints, code constraints. When it comes to DFMA content or prefab or IC content, the constraints are really important, right? Because that is what's going to ensure whatever hits the factory or hits the job site can be assembled, can be manufactured. So that handoff has to be really, really tight, and the constraints need to be followed, but often they're not, right? And that could be because of miscommunication. The teams just have out-of-date information. And what happens, again, I talked about that risk profile going up. At best, if the constraints aren't adhered to, the manufacturer catches them and will send it back for design revision, which is just churn and waste. At the worst, it does hit the factory floor, and then you're stopping the line, you're tearing things out, reworking things. So very, very costly. So we want to make sure that whatever trickles down to manufacturing is correct, that your BIM context is an accurate reflection of what can be manufactured. So the way we handle this with KitConnect, again, using our enterprise or project library of content, we take that kit apart and those rules and constraints, hand it off to the design team. So in this context, again, KitConnect works as a Revit configurator. It's really there to constrain the design team and make sure that they adhere to the rules. They have very few ways to paint outside the lines, as we would say. And then that's going to ensure that you get a really good handoff into manufacturing, because your Revit model is very, very accurate. It adheres to that data recipe in the cloud. And we have user permissions also that allow, that define who can do what in that Revit context. Revit's a really powerful tool, but it's really not good at constraining people. The other thing we can do is we can run an automated audit and check your Revit model against that data definition in the cloud. If anything is missing, out of version, out of date, just incorrect, we can go correct that model directly in Revit. I'll show you an example of that in a second. So first, let's show an example of creating a simple rule. We have really straightforward rule systems in KitConnect. This is sort of an optioning system. So I'm going to show an example of a flat pack building system. This is actually a Frog building system. Set of wall panels that are very interchangeable. But if I was to hand over these wall panels to an architect and say, here's just a bunch of Legos, go design, they may put objects in the wrong place. One example of a good example is this middle wall panel here looks pretty identical to the one on the corner. There's actually different connection constraints. The one on the corner is 5.5 inches wider than the one in the middle. So I couldn't just swap these out. That would be very hard for someone to understand just looking at these without the context of the rules. So what we're going to do is create a rule set that's going to focus on the middle part of this building and define what a designer can swap in and out in that section of the building. So I'm going to do that first by publishing the whole building as a module, because in KitConnect, modules own rule sets. So I'm going to publish this out as a module. I've already published all the walls and doors and windows as individual parts and assemblies. So now we'll hop over to our web application and we can observe that module in the web. And we came over here to make a rule set. So we're going to create what we call a part set. We'll call this north facade part set. We already have one for the south facade of the building. And once we've created that part set, I'm going to select 5 wall panels that are allowed to go in that portion of the building, that section of the building. So I'll select those from my content library. I'll add those to our part set. So now I've got 5 wall panels that are allowed in that zone. And if I use the switch part function in our module configuration tools, we can go and get that exact list that I created in the web. I can select a part to swap out, and I have confidence that I'm not putting something that can't be assembled in the field, that can't be manufactured on site. So as a designer, I have high confidence that everything I'm doing is an accurate reflection of the DFMA constraints. And I'll show one more example of using our audit functionality to constrain and make sure that you have an accurate Revit model. So this time we're going to focus on a volumetric module. And I'm going to show the wrong way to handle a design conflict using DFMA content, and then the right way to handle it using KitConnect. So we're going to insert that module using our insert module tool. I'm going to select a module preset and insert that module into my building design. And you can see when I drop this in, we're going to have a design conflict here. So I'm going to set that module in. And the design conflict is that I have, I can't get into the corner unit, right? I've got a wall here on both sides and an electrical panel that's in the way. So if I'm a designer that does not care about manufacturing constraints, I might just select that content and delete it, right? Gets it out of my way, solves my problem. I don't really care what happens on the factory floor. So that's out of bounds, right? That's going to create an inaccurate bill of material. Very crucially, you've lost an electrical panel that needs to be there. So if we say get content update, so we are running an audit of that model, we're going to see that something's missing. We'll just go put it back in the model. So make sure that you can't create a broken or inaccurate model. So if the correct way to handle that design conflict would be to select the module and switch it out for a different available option that somebody with knowledge of the manufacturing constraints has given to me. So now I've swapped that module out. You can see now the wall's out of the way, but very importantly that electrical panel did not get deleted. So I have an accurate bill of materials. I'm going to have an accurate handoff into manufacturing. And I know we're kind of getting close on time, so I'll try to move quickly through this last problem and I'll turn it over to questions. So the last problem, again, working in a data-centric way. You know, this is very typical across the industry, just a lack of data fidelity, siloed systems, everybody working in their own environments, everybody using spreadsheets and BIM and other tools and systems. How do you get these systems to talk better to each other? We're doing that primarily through that interaction between our Revit plugin and our web application, again, to allow all of those individuals to participate in that data flow. We've showed some examples already. I think the rules creation, that part set creation is a good example of, you know, why do we make the ability to create a rule accessible in the web, right? The example I showed would probably be, you know, somebody, a kit designer, somebody with manufacturing knowledge creating that rule. But you may have other rules that maybe a supply chain manager wants to create, right? It might be a list of plumbing fixtures that can be procured or bought out that you want to add to a rule set. That would be a non-BIM user creating a rule, and because we open that up in our web app, we create that accessibility of all of these different people to participate in that data flow. And the last example I'm going to show that I think kind of highlights sort of the power of that data recipe and opening up these workflows beyond just BIM is, again, we're going to show our Revit context and our web application here. This time we're going to focus on a bill of materials, and we'll highlight how we can do a very simple Revit model and get tons of information in an early stage of design as an example. So again, our web app on the right, you'll see we have the project BOM here, the bill of materials. It's completely empty right now. On the left side, we've got Revit, and we're going to insert a very low level of detail, just a simple bounding box representation of a module into our Revit context. So that to Revit, this is just a dumb box, but you're going to see KitConnect sees it as a much more intelligent box. So now our bill of materials is populated. So even though I only have just a simple box sitting in Revit, I have every single part and piece that sits inside of that module exposed to me in our web application. And that's, again, because we have that data recipe that lives outside the BIM context. So we're able to make that accessible to other users and get a lot of intelligence off very little amount of work in the Revit context. I could take that object and I could switch that module to a higher level of detail, bring in all those parts and pieces. You'll see though that the bill of materials doesn't change because the data is the data. The data in the cloud doesn't change. And just extending that concept further, we'll populate a full building. In this case, we're using Dynamo to populate a full building with a bunch of modules. And from there, we can get a very, very detailed bill of materials for the entire building. So this is an example of, you know, a building I could probably put together in about 20 minutes, just very low level detail. This might be feasibility study. you might be doing a bunch of iterations on a site that you want to procure, and you're just doing feasibility on, can we make this pencil out? So from a model that you could build in 20 minutes, you could get a pretty accurate estimate on cost from all those parts and pieces from the bill of materials. And then if I wanted to, I could switch over all of those objects to full level of detail. And then I'm pushing into more detailed design, DD, construction documents, so on and so forth. And that's just a good example of when you open that data up beyond the confines of BIM, other workflows that you start to open up, and other ways you can treat that data. So that's an overview of KitConnect and Project Frog. From there, I will open it up to questions.
Thanks so much, Mike. Great overview. It's exciting to even see further developments every time. So thanks you very much for that. If you want to write your questions in the chat, and while you're doing that, I'll just mention that also Project Frog has offered to allow you to use trial accounts, student accounts, if you want to play around with KitConnect, and Shirin has been coordinating that. If you want to use it for your projects, you can. We'll have some more information about how you'll be able to do that for your class projects as well. So this can not just be a kind of theoretical exercise, but you can get your hands dirty with KitConnect as well. So with that, I would love to see if we have any questions for Mike. If you want to put in the chat, or if you want to turn on your mic and your video and ask a real live in-person question, you're also welcome to do that. So.
Everybody's stunned into silence.
Yeah, sometimes it takes a while for people to write it out, but of course. But maybe I could ask one in the meantime then. When you're doing your audit, you're reconciling with the KitConnect online parts with the actual design and see if anything has been deleted. I imagine then also it's not so hard to develop new modules if the requirements call for it. If you don't have, for example, the right one that allows you to not delete the electrical box. So would you then go back and create a new part and just enter it into the system, and it'd be as easy as then now you select that new part? Or do you have to predefine the modules before you start the project?
You would. It depends on the context, but one thing to highlight is that we have user roles. So if you had permissions to go create a new module, you could do that. If you're a user that doesn't have permissions, then you'd have to go ask that person, right, who has that permission. And I think that's the important thing. We're trying to create that dialogue there, that don't just go do whatever you want. There's somebody, if you don't see an option that works, it probably means there's a reason for that. If you need something different, go talk to that person. They might tell you no, right? They might say, we don't manufacture that module that way, right? And that creates a dialogue that's really important in a DFMA workflow, right? So that's a big piece of what we're trying to accomplish there. Eventually, we want to get to a point where we have better ways to hand off for approval in a more automated way and create an approvals queue. Right now, it's just a simple, like, go email that person and ask for a different design option.
Yeah, good. And I appreciate the reinforcing the message that we don't want to design things that can't be built, which is something we've been talking about in class for the last couple of weeks. We have a question from, I think it's from Adrian. Could I describe KitConnect as a definitive BIM integrator?
A BIM integrator. I need to understand a little bit more about what that means, a BIM integrator. Is there can you qualify what you mean by integrator?
Yeah, feel free. If you're not too shy, you can also turn on your video. That's okay.
Okay.
I'll see if he's there.
Okay, so legal regulations, constraints. So Yeah, that we get that question a lot. We have not attempted to solve for like regulatory or code constraints. What we're trying to do is create a easy to use framework or system to create rules, right? And that could be whatever rules or constraints that you see fit. So it's a really open system. So for one, for one user, that could be how a furniture system goes together. For another user, you might create a lot of content that has, already your different, handicap accessibility spaces built in, right? That can't be edited. And that's really up to the end user. The code, code is so variable and regulatory is so variable. And the types of rules and constraints that different companies will use are so varied that we just want to create a kind of an open generic system to allow them to achieve that.
Good. We have a question, and this I think will be our last one because I know we're a bit over time. Is Project Frog aiming to develop more customized or even project-specific bespoke kit of parts for complex projects such as complex geometry freeform?
Yeah, that's an interesting one. I think it depends. We focus. We're still developing kits of parts for a lot of companies. We focus on what I would call more mass market buildings. For us, there needs to be volume and scale. So in one example, one company we're working with, they build 100 buildings a year. So we're really focused on that, right? And those are typically not as complex of geometry or freeform geometry, but there's so much to solve for just the rectangular buildings that most of the world is made up of. That's where we really focused our efforts and trying to hone in those tools and systems and processes to make that scale.
Okay, so thanks for those answers, Mike, and for the great guest lecture. Really appreciate it as always. Usually we clap at this point, but we just kind of, I guess, everyone can leave thanks in the chat if you wish. From my side, very appreciative of it. For the class, we actually have 2 weeks off. So next week we're off for Easter, and the week after we're off for Sexelautzen holiday. But you will have a prompt from Firhiwat on the next challenge for your teams. So look for that video. And then we come back together in, I think, 3 weeks from today. We'll have our next class lecture. And I think we will be hearing from the Swiss company Erne and also hear about the DFAB house. So in the meantime, continue working in your project teams. If you have questions, put them on the class Jamboard. So the project teaching team, we can answer any questions you have about the project. I'll be checking in, even though we're not meeting. Yeah, best of luck as you keep working on your projects. And thanks again, Mike. So
thanks so much. Great, very fun. Yep. Always enjoy talking to these students. It's great opportunity. Thank you. Stay safe, everybody.